Hi, this instructional video is about dilation. Dilation. And this one particularly is about a dilation where the center is not at the origin. In fact, the origin is going to be at -4, -4. So let's go ahead and plot that. Here's 1, 2, 3, 4. 1, 2, 3, 4. And so right there, way down here, where the, 7 o'clock would be at the third quadrant. And the coordinate for that is the center is, coordinate is -4, -4. That's the center, not the origin. And now from here, we're going to reduce this polygon with 4 vertices. And we're going to reduce it because the scale factor is less than 1. It's 2/3 of it. So let's go and plot these 4 vertices and get a picture of what this is supposed to look like. Okay? Here we go. Alright, so it appears we have what looks like a trapezoid. I'm not sure exactly, but it looks like the distance is equal. Alright, so now what we're going to do is we're going to reduce it. And to do that, we have to know the units from the center to each of the vertices. So for example, let's do it this way. So first, let's find the distance from the center to the coordinate A, the translation that is, the horizontal and the vertical shift. So to go from here to the A, we have to go 1, 2. So x plus 2. And the y value, we're going to go up, so it's going to be positive. 2, 4, 6, 8, 10, 12, 14. So y plus 14. That's going to be the horizontal and vertical shift. And now what we're going to do is we're going to take the total number of x and the y translations, and we're going to take 2/3 of it to reduce the distance by 2/3. So let's go ahead and do it this way. So take the 2, and we're going to take 2/3 by multiplying it. That becomes 4/3. And we're going to do the same thing with the y. 14 units, and we're going to reduce it by 2/3. That's going to be a, what, 28/3? So that is the distance, or the 2/3 of a distance. However, now we're going to take that, and we're going to now find the actual coordinate by subtracting from here to the center. So that means 4/3 minus, because it's -4. So that's like saying 4/3 minus 12/3, because 12/3 is like saying 4. So same old denominator, so that's -8/3, or that's basically -2 2/3. And we're going to do the same thing with the y value of 28/3 minus the y value -4. Okay, so that becomes 28/3 minus 12/3 again. 28 minus 12 is going to be, what is that, 16/3? Or that's going to be 5 1/3 when I have to plot it. But this is the actual coordinate. So that's like saying -2 2/3. So that's -2 2/3 is like over here. And y is 5 1/3. So 2, 4, 5 1/3 is like over here. And that becomes A prime. And the coordinate is right there, -8/3 and 16/3. Wow, that was a little spicy, wasn't it? And you have to repeat this for every vertex. So again, this time from the center to the coordinate B. So the translation, to go from here to there, the horizontal shift is 2, 4, 6, 8. 8 units to the right. So that's x plus 8. And the y, we have to go up. So let's count that. 2, 4, 6, 8, 10, 12, 14, 16, 17 units up. So plus 17. That becomes a translation. Horizontal and vertical shift. And we have to take that total shift, that number of units, and we have to take 2/3 of it. So 8 times 2/3 is like saying 16 over 3. And 17, we're going to take 2/3 of that as well. So that's going to become 34. Boy, the numbers are looking pretty ugly. But that's the total distance. Okay, that's the total distance. Now we have to find the actual coordinate. And to do that, we have to find the difference from the center. So 16 over 3 minus 4. That's like saying 16 over 3 minus 12 over 3. And that's going to be, what's that, 4/3? For graphing purposes, it's like saying 1 1/3. And 17, where did it go? 34 over 3 minus the original 4. And that's going to be like saying 34 over 3 minus 12 over 3. So that's going to be 22 over 3. Or that's going to be what? 7 1/3? But this is the actual coordinate right here. That's the actual coordinate.